What's up, everybody? It's Dan from sagemathtutoring.com, and I have a new student who is just starting his SAT math prep with me. So I want to make a quick video just kind of going over some of the problems that you might have to face on the SAT, like the kinds of problems. So let's just get started. We're going to jump right into it. Painter will paint end walls with the same size and shape in a building using a specific brand of paint. Painter's fee can be calculated with the expression NKLH, where N is the number of walls, that's N is the number of walls, K is the constant with units of dollars per square foot. Right, L is the length of each wall in feet, H is the height of each wall in feet. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change? Well, I think a good approach to this question is to ask yourself what wouldn't change. So if you're using more expensive paint, what would not change? Well, what would not change is the number of walls. What would not change is the length of each wall. Obviously, that's going to stay the same. The height of each wall is going to stay the same. So that leaves us with K, which is a constant with units of dollars per square foot. So that looks like K is such that the more expensive it gets, the bigger K would get. So in this case, the answer is C. And again, you could also use the reverse logic in the sense of asking yourself which of the expressions would not change if the painter was to use more expensive brand of paint. All right, so that's number one. Number two, if 3r equals 18, what's the value of 6r plus 3? Okay, so a good thing to do right out the gate is just solve for r. It's easy enough, certainly. So it's 3r equals 18, dividing both sides by 3 is r equals 6. And then therefore, when you're looking at 6r plus 3, that's going to be 6 times 6 plus 3, also known as 39. So that would be the answer there. All right, which of the following is equal to a to the 2/3 for all values of a? Okay, so I'm just going to go off to the side and just be like, imagine we had x to the 3/4. Well, if you want to rewrite this into sort of a radical form, I like to think of tilting the fraction in that direction, like tilting it over to the right. So this would therefore become x underneath the radical symbol, but this 3 is now tilted, so it's right here, and this 4 is also tilted, so it is there. So once again, just thinking of that fraction as rotating. You could think of it that way too, rotating clockwise, right? And then 3 ends up here, 4 ends up here. So if we were to take this 2/3 and similarly rotate it clockwise, we would see that it would turn into answer choice D. All right, so this really just has to do with being familiar with the laws of exponents. I think another thing worthy of note as well is anytime you raise something to the 1/2 power, that's the same as taking the square root of that thing. And it's really for the same reason, because you can think of that 1/2 as tilting, and the 2 ends up here, and we have a 1 right there. Now, we're not used to seeing a 2 here, but whenever you take the square root, a 2 is secretly there. It's like this invisible 2 is hanging out there, okay? You can think of it as the second root of x, also known as the square root of x, okay? So that's just something to keep in mind just in general for the SAT. The number of states that joined the U.S. between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. So already we're realizing that more states joined in the past. Okay, so back in this time period, more states joined. If 30 states joined the United States between 1776 and 1849, and X states joined between 1850 and 1900, which of the following equations is true? So this is a classic example of a problem that is really not that hard, actually, but it's annoying to read. So from 1776 to 1849, we had a certain amount, of states joining, and from 1850 to 1900, we had a certain amount of states joining. Now, according to the information, it was 30 states that joined here, and according to this information as well, this 30 is twice the number of states that joined between 1850 and 1900. So clearly this is going to be 15 right there. So if that's twice the number of states that joined as during this time period, then clearly that's going to be half, which is 15. And then you just have to sort of ask yourself, well, what do they mean by X? X is the states that joined between 1850 and 1900. So actually 15 equals X is what we're seeing. And anyway, you just kind of make all these mental notes. You could literally write it down if you have to. But nonetheless, you look at the formulas and you just ask yourself which one of these would result in the truth, So is it the case that 30 times 15 equals 2? Absolutely not. Is it the case that 2 times 15 equals 30? Absolutely. Therefore, answer choice B is the answer. So in other words, using the X, we already discovered 15 equals X. Plug X into the answer choices until you get the one that actually works, right? 2X certainly equals 30. All right, so for this one, if 5 over X equals 15 over X plus 20, what's the value of X plus 5? All right, so the first thing to take note of is we are not being asked to find X, we're being asked to find X plus 5, or X over 5, I should say, right? So you want to be careful with that. The SAT math is going to bait you a lot to, get you to solve for something, and really what they're asking for is something else. So always make sure you're answering what they're asking for, and maybe even underline it or circle it or whatever. So for that reason, I don't want to use the strategy of plugging in 10 for X and so on, because again, we're not looking to see what X equals, right? So I don't want to plug in the answer choices for X. What you are going to have to do here is really just cross multiply. All right, so I believe probably most people are familiar. Let's cross multiply. That would end up with 5 times X plus 20 equals 15X. Distributing the 5 gives me 5X plus 100 equals 15X. I'm going to subtract 5X from both sides, and that's going to give me 10X equals 100. And then dividing both sides by 10 gives me X equals 10. Now, once again, be careful. We want X over 5, so that will be 10 over 5, which is also known as 2. So that is the answer. XY is a solution to the system of equations. What is the value of X minus Y? All right, so obviously there's elimination we could use. There's substitution we could use. Both should work. It's often the case that there's going to be an easier way to solve what would otherwise be a time-consuming problem. And I think it's worth just simply recognizing that they're not asking for X, they're not asking for Y, they're asking for X minus Y, correct? So in other words, there might be a way to solve this in such a way that does not require us to know what X is or Y is. All we really need to know is what X minus Y is. I do not see any opportunities to cancel anything using the process, like the elimination method here. But I am curious. I see this 2 and 3 and a 2 and 3 here. So I'm curious to see what happens when I add the top to the bottom. So let's take a look. We have 2X minus 3Y equals negative 14. We have 3X minus 2Y equals negative 6. And I'm literally going to add the bottom to the top. And clearly we have 2X plus 3X. That's going to be 5X. The negative 3X plus negative 2Y, or negative 3Y plus negative 2Y is going to be minus 5Y. And then finally the negative 14 plus the negative 6, that's clearly going to be negative 20. Now, I see this X minus Y kind of shenanigans that sort of resembles what I'm looking for. So I'm asking myself, can I turn this into something where it just says X minus Y? Well, sure enough, we have a GCF of 5 and 5. So I could factor out 5. And I have 5 times X minus Y equals negative 20. And if I divide both sides by, 5, then of course these would cancel, and I am left with X minus Y equals negative 20 divided by 5 is negative 4. And that is actually the answer right there, because again, they're asking for X minus Y. Well, we just solved for X minus Y, so that's that one. Okay. The function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? Right. Okay, so factors help reveal the x-intercepts. That's the crucial insight here. So for example, if I had a polynomial that said x squared plus 7x plus 10, well, if I was to factor that, that would be x plus 2 and x plus 5. And then I would soon realize x equals, negative 5 and negative 2. Now, for the sake of, moving fast, just know that if you don't have a coefficient other than 1 in front of the x, this is really just 1 times x right here, and then we have 1 times x here. If it's like that, as opposed to 3x and 4x or something, then you know the sort of x-intercepts by just looking at this number and choosing the opposite sign. So the 2 gives me the negative 2, this 5 gives me the negative 5, right? For the sake of brevity, I'm just going to say that for now. Now, what this basically reveals is, where this graph crosses the x-axis obviously here, y-axis obviously there, and then we have negative 5, and then we have a negative 2. So maybe this is a parabola that crosses like that. Now, what do we know for sure about these points of intersection? Well, the one thing we know for sure is that the y value is 0. Okay, so in other words, the coordinates of the first x-intercept are as follows. The coordinates there are negative 5, comma 0, and the coordinates right there are most definitely negative 2, comma 0. So one thing you know for sure about x-intercepts in general is that they always correspond with a y value of 0. All right, that is definitely helpful information to remember. And how does that help us with this situation? Well, first of all, it's good to think of f of x in this context as y, right? And if these are factors, like these are little factors that, are kind of like this situation, right? It's, kind of like that. Only we don't know the polynomial. We don't know the polynomial here, but, these are potential factors of whatever the polynomial is. Well, basically, you want to scan this column for any y values of 0, and you certainly see in this row we have an x-coordinate of 4 and a y-coordinate of 0 right there. So that means 4 is an x-intercept. Now, what did we say about the x-intercepts here? You had a negative 2 corresponding with this 2. You had a negative 5 corresponding with this 5. So again, the x-intercepts are always going to be the opposite sign of what's actually inside the factor. The x-intercept is going to be the opposite sign of what's actually inside the factor. So this x-coordinate of 4 right here is going to be the opposite sign of actually what's inside the factor. So hopefully that makes sense. It's kind of a roundabout way of saying it. But another way of saying it is that if x minus 4 was a factor, then you would most definitely have, just based on that information, an x-intercept of 4, comma 0. No question about it, because if that's a factor, then this would be an x-intercept for sure. And where in the table do we see 4, comma 0? Well, it's right here. All right, the line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point CD, where C does not equal 0 and D does not equal 0, what is the slope of the line in terms of C and D? Okay, well, this one's actually pretty easy. It doesn't even require the slope formula. For the record, the slope formula is this, which is something that definitely comes in handy on the SAT math. But the good news is with this, we don't even really need it, because basically they gave us the equation of a line, and they gave us a point that the line goes through. So here's the equation of a line right here. And, apparently it goes through the x value, basically when x is C, y is D. That's essentially what this says. It is the case that when it comes to this line, when x is C, y is D. So that means I could replace y with a D, and I could replace x with a C, and that won't, break any rules. And why did I do that? Well, why am I replacing x with C and y with D? Well, because they want to know what's the slope, what is k, in other words, because k is the slope. What is the slope of the line in terms of C and D? So let's review this final question right here. What is the slope of the line in terms of C and D? Whenever they ask, what is blank in terms of C and D, it means solve for blank. So if it says, what is the slope of the line in terms of C and D, that's fancy code word for saying solve for the slope of the line, which is fancy language for saying solve for K, okay, because K is the slope. So in order to do that, I would certainly subtract this 4 from both sides, and we will have K times C equals D minus 4. And once again, solving for K right now, I would have to divide both sides by 4, or by C rather, and that would give me D minus 4 all over C, which is the answer, and that is found right there. Hopefully that makes sense. Okay, and the system of equations above K is a constant, and X and Y are variables for what value of K? Well, the system of equations have no solution. Okay, a system of equations has no solution if the lines, represented by each of these equations are parallel to each other, all right? If the lines represented by each of these equations have the exact same slope, aka they're parallel, then we say that the system has no solutions, all right? Now, when that's the case, there's an actual little known trick of the trade that you could totally employ here. This works if the system of equations have either no solution or infinite solutions, okay? So the following trick of the trade that I'm about to go over only applies if it's the case that the system of equations has either infinite solutions or no solution. Now this has no solution, so we can do this trick of the trade. Here's the trick of the trade. You make sure like is stacked over like. Now they were kind enough to do that for us. We have the x terms over the x term, the y term over the y term. We have a constant over the constant across from the equal sign. All right. Now what you can do from there is only pay attention to the coefficients of the x terms and the coefficients of the y terms, and you can go off to the side or down here and literally make a fraction out of the coefficients of the x terms. See, it's like k over 4, and you can set that equal to the coefficients, a fraction made out of the coefficients of the y terms. So we have negative 3 over negative 5, and now we can literally just solve for k. Obviously, we'd be cross-multiplying, and that would give us negative 5k equals negative 12. Dividing both sides by negative 5 would give me 12 over 5, because the negatives would cancel. And that is the answer to that one. All right, in the xy plane, the parabola with equation y equals x minus 11 squared intersects the line with equation y equals 25 at 2 points A and B. What's the length of AB? All right, first of all, it's a good idea to get an idea of the visual of like what's happening here. You don't have to be totally precise, but first of all, that's a horizontal line. Y equals 25. Anytime it's like y equals some number, it's a horizontal line. So, I don't know, here's 25, right? And imagine a line going through it like that. And then we have this like parabola thing. Now, I don't know, maybe the parabola is like that or something, for all we know. Not really sure, but maybe it's like that. And, what does it say? It intersects the line at 2 points A and B. So we can imagine this is point A. We can imagine that's point B. And we want to know, what is the length of AB? In other words, what is the length of the segment between A and B? Well, that's pretty easy. Basically, since this blue line is horizontal, since y equals 25 is horizontal, the length of this segment right here is only going to be the difference between the x coordinates, right? If you think about it, right? The difference between the x coordinate here and the x coordinate here, well, that's going to be the distance between A and B, points A and B. So basically our first mission is to find the x coordinates. Well, we know the y coordinate for sure of like B and A, right? The y coordinate is 25, right? In case that's not clear, I'll kind of zoom in and we could really just think about it, I'll call the first point right here. This will be x1, comma 25. And this point right here, I'll call that x2, comma, 25, right? Because think about it, the y-coordinate is definitely 25. Why? Because this horizontal line cuts through the y-axis at 25. So we have a y-coordinate of 25 here. We have a y-coordinate of 25 there, right? So why is that helpful? Well, that's helpful because basically what that means is we can totally just be like, all right, if I want to find the x-coordinates, well, all I have to do is just pick this equation right here where there is an x in the first place, set y equal to 25, and then solve for x. So we're going to do that right now. Do that right now. So we have 25 equals x minus 11 squared. And in order to solve for x, I'm going to want to take the square root of both sides. And don't forget to do the plus minus shenanigans there, right? So we therefore have, let's see, 5 plus minus 5, I should say, equals x minus 11. So let's see. So that means one of two things. It might be helpful to just separate this into two different equations. We have x minus 11 equals positive 5, and we have x minus 11 equals negative 5. Let us figure out the first one first. So adding 11 to both sides would give me 16, and in this case adding 11 to both sides would give me 6. So in other words, this x over here is the larger of the two, which is 16. This x over here is the smaller of the two, which is 6. And in order to find the distance between two different x values, you always just subtract the smaller from the larger. Always subtract the smaller from the larger. So that's literally going to be 16 minus 6, which is 10. So that's the answer there. All right, in the figure above, lines K, L, and M intersect at a point if x plus y equals u plus w, which of the following must be true. Roman numeral 1, x equals z. Roman numeral 2, y equals w. Roman numeral 3, z equals t. All right, so this is a good problem. See, basically, the answer choices are Roman numerals, basically. But in a way, the Roman numerals correspond with these variables, right? So in a way, the answer choices correspond with variables. So whenever there's variables in the answer choices and variables in the problem, it might be a good idea to make up your own numbers. So I'm going to do that right now. So let's say that we want to call this is 50 and this is 45. Now, what do we know? If it's the case that this is 50 and this is 45, well, guess what else is 45? U is 45, yes? 45. And if this is 50, what else is 50? Well, clearly T is 50. So that's just something you can kind of play with right away, is make up your own numbers and just assume that that would be helpful, seeing as how there's variables in the answer choices and variables in the problem. Now, according to them, x plus y equals u plus w. So according to them, this equals this, right? According to them, when you add this angle plus this angle, which, makes this bigger angle, and, denoted by the blue arc, well, that big blue arc angle equals w plus u, or u plus w, which when added together gives me this green arc angle, right? So in other words, 50 plus 45 equals 45 plus what over here? Well, w has to be 50, right? I mean, if this blue arc angle equals this green arc angle, and that's 45 and that's 45, then w has to be 50. So we could just very confidently label this as 50 degrees. Now, once you do that, then you know for sure that z is equal to 50 degrees, yes? So basically, now you just go through the Roman numerals and see which ones would work. Is it the case that x equals z? Well, x is 50 and z is 50, so that certainly checks out. You could literally put a check there. Roman numeral 2, y equals w. Is it the case that 45 equals 50? Absolutely not. That is gone. Roman numeral 3, is it the case that z equals t? 50 and 50, yes, that does check out. Roman numeral 1 and Roman numeral 3 certainly work in this case. Now, sometimes you're going to pick numbers that do end up working, but it so happens that, this is asking which must be true. you might end up picking numbers that only, for example, work with Roman numeral 3 by coincidence. Or, you might end up picking numbers that only work with Roman numeral 1 by coincidence. So you do want to keep that in mind, and the remedy to what I'm talking about is you might want to try other numbers as well in addition to these numbers and just do a quick run through to see if, is it the case that under all circumstances, regardless of what numbers I pick, it would be the case that Roman numeral 1 and Roman numeral 3 would both work. And you would see, like, for example, if you chose 47 and 51, well, it would lead to the exact same situation. If that was 51, that would be 51. If that was 47, and then that would be 47. Since this equals that, well, this would have to be 51, which makes that 51, and then all the same, relationships would apply. Hopefully that makes sense. Okay, so this one, in the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD, which of the following is equal to D. Okay, so yeah, D is the y-coordinate of the vertex. Now, this is sort of an interesting, maybe less common way of writing the equation for a parabola, okay? But this is a way to write the equation of a parabola because it's actually helpful because it helps us see what the x-intercepts are. I alluded to this in an earlier problem where, this isn't a parabola where the x-intercepts are at 2 and -4. So I'm actually going to draw something that looks a little bit like that. Now, how do I know? Because this is such that this first parentheses tells me that, y is 0 when x is 2, and therefore, the point 2 comma 0 is an x-intercept, and this parentheses tells me that y is 0 when x equals -4, and therefore the point -4 comma 0 is indeed an x-intercept, which is over here. So why do I care? Well, you'll see in a moment, but before I do, I would like to label these. So we have 2 comma 0, and over here we have -4 comma 0. And how does that help us? Well, we know that the vertex is this point right here that's at the bottom, which is, as far as the x coordinate for the vertex. And by the way, the vertex is CD, so let's denote that. CD. We know that this x coordinate C is perfectly in between the x value of 2 and the x value of -4, right? C is perfectly in between, and that corresponds with -1. So in other words, C comma D is really -1 comma D. Now, you might be asking, how did I know that? How did I know that -1 is perfectly in between 2 and -4? Well, in case you're ever not clear about how to find the midpoint between 2 points on the x-axis, you just take the x values, in this case it's -4, you add it to the other x value, which is +2, and then you just divide it by 2, and that would give you -1, right? So to find the midpoint between two x values, you add the x values divided by 2, and that would give you a -1. So that's how I know that at least the x-coordinates of the vertex is -1, which corresponds with C. So in other words, C is definitely -1. Now, how can we use that information to find D, right? Well, according to this point, whenever x is C, y is D, right? Whenever x is C, y is D. Okay? So I'm going to, take advantage of that knowledge and literally set y equal to D right now, and I'm going to set x equal to C. So y is equal to D. We still have this a. We don't know what a is. But x is C, so that's going to be C minus 2 and C plus 4. And we want to figure out what is D. Well, I see A's down here, so apparently we're not going to need to know what A is. A is just minding its own business, and that's fine. We're going to leave A alone because according to these answer choices, we don't even need to know what A is because A is present in each answer choice, so we're going to leave that A there. But one thing we could do for sure is we could sort of simplify this side. Now, how are we going to do that? Well, we know what C is. It's -1, so let's take it one step further and say that D equals A times -1 minus 2 times -1 plus 4. And simplifying that gives me D equals A times -3 times 3. And simplifying that gives me D equals A times -9. And that is why this is the answer. A, -9A is the answer. So once again, what did we do? We took into account the fact that the, x-intercepts are clearly at -4, 0, and 2, 0. Therefore, the, vertex is perfectly in between them with an x-coordinate of -1. That -1 corresponds with C because they gave us, vertex is C, D. -1 is right here. We took into account the insight that, according to this information, whenever x is C, y is D, according to this point. Whenever x is C, y is D in this equation. So we set y equal to D, we set x equal to C, and then we reminded ourselves that C is most definitely -1, and then we plugged that in, we substituted -1 in for C, and we simplified. We ended up with D equals A times -9, which is right there. And that's what they're asking for. They want to know what does D equal. Hopefully that makes sense. Okay, the equation 24x squared plus 25x minus 47 all over this equals -8x minus 3 minus 53 over ax minus 2. And that's true for all values of, where x doesn't equal 2 over a, where a is a constant. What's the value of a? Okay, so we want to find out the value of a. Now, one way to go is to plug in these answer choices until, something works. This is sort of unavoidably a tedious problem as far as I can tell. One thing I'll say to you before we begin is don't worry about this. This is basically the SAT covering its butt by letting you know whenever you see x does not equal 2 over a or some shenanigans like that. That's just basically their way of saying that these fractions are not undefined. You can rest assured that the denominators are not 0, and therefore you're not dealing with undefined fractions, okay? So in a way, you can kind of ignore that. This is not that important for the problem. One thing you do want to do, though, is obviously figure out what a is. I'm hesitant, again, to plug in like -16 and all that. I'm a little hesitant to do that because it's unavoidably time-consuming. One thing that you might want to consider, there's a couple ways you could go about this. One thing you might want to do is try to get this thing to sort of match this thing, and then you could therefore compare apples to apples and then figure out what a is from there. In other words, if you could get this side to, if you could somehow force this side to look something like this side, then it would be such that you could compare the terms to each other and match like with like and then figure out what a is from there. I'm going to go that route. There's another thing we could do that has to do with like long division that is good if you're familiar with, polynomial long division, but a lot of people are not. So instead I'm going to rely more on like a regular algebra approach. So I have 24x squared plus 25x minus 47 all over ax minus 2. And that equals -8x minus 3 minus 53 over ax minus 2. Now, I do not like these ax minus 2 denominators. I prefer to get rid of them. Okay, I prefer to get rid of them. And the way that you could do it is you could literally multiply both sides of the equation by x minus 2. Now you have to keep in mind I am multiplying the entire right-hand side of the equation by ax minus 2. So why would I do that? Well, First of all, over here, what that does is it cancels that ax minus 2. So I'm actually just right now going to write 24x squared plus 25x minus 47 by itself on that side of the equal sign right here because these just canceled. Now, on this side, it is a little bit trickier where, in a way, you're distributing this ax minus 2 to this term, and you're distributing it to the 3 to be fair, and you're distributing it to the negative 8x to be fair. But you can kind of think about this negative 8x minus 3 as its own term, and you are going to be distributing, the ax minus 2 here, and you're going to be distributing the ax minus 2 to that guy, okay? So right now, I'm going to sort of denote that first situation where it's negative 8x minus 3 times ax minus 2. And we are subtracting the 53 over ax minus 2 times ax minus 2. And then these cancel. So that effectively gets rid of the denominators here. So I'm going to leave this ax minus 2 over here, this little double parentheses. But what I'm going to do on the next line is I'm going to rewrite the left-hand side because nothing's really changed there. 25x minus 47. And then we have negative 8x minus 3 times ax minus 2 minus 53. And then what you could do here is you could FOIL this right now. So I'm going to do that right now. I'm going to once again rewrite the left-hand side. I'll use green, plus 25x minus 47. And that equals, first times first is negative 8ax squared. Outer times outer is positive 16x. Inner times inner is negative 3ax. And then we have last times last, which is plus 6, and we still have that minus 53. And bottom line is, this 6 minus 53 is going to correspond with a negative 47. All right, so hopefully that is clear. And also, when I combine this x term, these two x terms, that's going to correspond with 25x. But the good news is we could just kind of focus on the term that has the x squared in it, which is this, right? We can focus on that term. And this is what I'm talking about, where I can now compare like to like. So in other words, I forced this side to look at least something like that side. The first step was to get rid of the ax minus 2 denominator, which I did by multiplying both sides by ax minus 2. So I brought it down to a single-story building here. And now I'm foiling this out. And we're seeing the first glimmer of that x squared term over here and what the x squared term is supposed to be. It's this. So I know for a fact that negative 8ax squared equals 24x squared. So I can actually go off to the side and just focus only on that because remember, we're only interested in what a equals, right? One thing we could do right away is, we want to get a by itself. So let's divide both sides right now by negative 8x squared. Negative 8x squared. And the reason we do that is because that would cancel the negative 8, that would cancel the x squared, leaving only this a on the right-hand side. So I'm going to have a equals, well, what is 24 divided by negative 8? Well, that's negative 3. And then we have x squared over x squared, which just cancels out. So a equals negative 3. We are actually done. That is the answer to that one. So it's, the answer to that one is most definitely B. And hopefully that makes sense. Pause the video, rewind if need be. Okay. What are the solutions? 3x, blah, blah. Okay, so this all looks like the kind of solution you would get if you use the quadratic formula, which, by the way, is this. Negative b plus minus b squared minus 4ac all over 2a. And they want the solution, so I say we literally just use the quadratic formula to figure out what the solutions are. Now, let's be very clear. A in this case is 3, B in this case is 12, C in this case is 6, because this is A, this is B, and this is C. So I'm now going to use the quadratic formula right now by saying x equals minus something. I always like to do the parentheses first, that's just me, and fill it in after. Part of the reason I like to do it this way is because it prevents careless mistakes with regards to negatives. Even though there are no negative A, B, or C's here, it's still a good habit. So B is 12, that goes here and here. A is 3, that goes here and here, and C goes as 6. So yeah, it's really just a matter of like simplifying this, you know. Negative 12 plus minus, okay, let's be very clear, that's 144. Minus 72, which is radical 72. And then you have a 6. And then we have negative 12 plus minus radical 72 simplifies to 6 radical 2. And that's still over 6. Now, in a way, you could be like, okay, well, that's the answer. Well, where the hell is it? You know, I don't see it anywhere. Well, the bottom line is you see how you have two terms separated by a plus minus. So basically what that means is that what they did is they split this into something that looks like the following, where it's negative 12 over 6. So in a way, they split the denominator, all right? Because think about it, I could hypothetically go from here to there, right? Whenever you have a fraction plus or minus another fraction and you have the same denominator, well, that's the common denominator. What do? You keep the denominator and you simply add or subtract the numerators, which is right here, right? So you can, anytime you have like this top-heavy fraction and the numerator consists of terms that are separated by either addition, subtraction, or both, you could then split the denominator. And this would, you know, most definitely simplify into negative 2 plus or minus radical 2, because these cancel. This turns into a 2, that turns into a 1. These both turn into a 1. We are done. That is literally the answer. And moving on. All right, the equation above shows how temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius based on the equation which of the following must be true. Temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Okay, we could think about that. Temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature of 1 degree Celsius. All right, well, this one right here is sort of asking us to think in terms of, like, you know, F in terms of C, where, you know, F is the dependent variable and C is the independent variable. So if it's not clear what the heck I'm talking about, it will soon. So basically, I like this equation and everything, but let's figure out what F is in terms of C. So I could do that by multiplying both sides by 9 over 5. So I will start by rewriting the original and multiply both sides now by 9 over 5. And what does that do for us? Well, that most definitely cancels here, which is why I'm doing it, by the way. And on the next line, we would therefore have just f minus 32 equals 9 over 5c. And if I wanted to solve for f, all I have to do is add 32 to both sides, correct? So adding 32 to both sides, I'm just going to write it, would give me 9 over 5c plus 32. Now, the reason I'm doing that is because I want to give myself two equations to work with, because I could see how this equation is going to come in handy for Roman numeral 2. All right, now let's analyze Roman numeral 1 right now. Roman numeral 1, what does it say? A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degree Celsius. So is that true? Well, I don't know. Here's the original situation, right? F minus 32. Well, if I was to distribute the 5/9 there and there, it would be 5 over 9 F minus, 32 times 5 is 160, so that's going to be 160 over 9. So basically what they're saying is, what would happen if this, instead of F, it was F plus 1? That's essentially what they're saying. How would that affect C, right? Well, let's experiment with it. Imagine we add 5 over 9 times F plus 1, and it would be that. Well, basically what that would do is we would then have 5 over 9, and if we were to distribute it there and there, we would then have 5 over 9 plus, 5 over 9F plus 5 over 9 minus 160 over 9. And what does that become? Well, that becomes 5 over 9F, minus 160 over 9 plus 5 over 9, right? And basically what you could see is that this part is totally the same as the original part. So this part right here is totally the same as that part, only we're adding 5/9. So what we've just learned here is that when you add 1 degree to the Fahrenheit temperature, it results in a situation where you have the same as the original, only plus 5/9. So Roman numeral 1 is true. Roman numeral 1 says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degree Celsius. Well, this is, C. This is C plus 5 over 9, right? Because C is 5/9 F minus 160 over 9. So this is the same thing plus 5/9. So this is C plus 5/9. So this is, an increase in the Celsius temperature of 5/9. So Roman numeral 1 works. Roman numeral 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Well, I am now going to use this other equation right here to analyze that situation. So basically, let's see what happens when we have a 1 degree increase of C. So that would be C plus 1 plus 32. Well, this results in, obviously, going to have to distribute there and there, and then you would have 9 over 5C plus 9/5 plus 32. And basically that is 9 over 5C plus 32. I'm just going to rearrange the order by which I write these, plus 9 over 5. And then this part right here is the same as the original equation. So 9/5 C plus 32, well, that's this. But when we add 1 degree to the Celsius, what happens? We get this extra 9/5 of a degree, right? Well, 9/5, if you were to, work that out, either by turning into a mixed number or doing long division or whatever, with decimals, you would realize that 9 over 5 equals 1.8, definitely. So Roman numeral 2 is also true. A temperature increase of 1 degree Celsius, when you add 1 degree Celsius, that does result in a situation where you have the original equation only plus 9/5, only plus 1.8. So 1 degree increase in Celsius does indeed result in 1.8 degrees Fahrenheit. Hopefully that makes sense. Okay. So, and then finally, looking at Roman numeral 3, temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. Well, that's untrue. And we know that that's untrue because when there's a temperature increase of 1 degree Celsius, it results in a temperature increase of 1.8 degrees Fahrenheit, not 5/9 degrees Fahrenheit, right? Our analysis with Roman numeral 2 disproves this. According to Roman numeral 2, which is true, when there's 1 degree increase Celsius, that corresponds with 1.8 degree increase in Fahrenheit, whereas this is saying that when there's 1 degree increase in Celsius, that results in a 5/9 degree increase in Fahrenheit, and that's not true because 5/9 is not equal to 1.8. That's gone. Hopefully that makes sense. Therefore, the answer to this is Roman numeral 1 and Roman numeral 2, which is right there. Okay, so x is greater than 0. What is one possible solution to the equation above? All right, so first of all, it might be obvious to some that if x was 0, well, that would be true because this would be, 0 times whatever, which is just 0, and that would be negative 4 times 0, which is just 0, and 0 equals 0. But according to them, we're not allowed to have x be 0. X is actually greater than 0. So you have to kind of go through a separate methodology to figure out what x is. So one thing you could do here is you could distribute that x cubed, among other things, which we're going to do in a moment. So if I was to distribute that, this would become x to the 5th minus 5x cubed equals negative 4x. And let's set this whole thing equal to 0, just because that's often a good idea when it comes to polynomials and solving polynomials. So we have plus 4x equals 0. Definitely a good idea to factor out the GCF. In this case, it is x. So we have x to the 4th minus 5x squared plus 4, and that equals 0. Now, again, we already acknowledged that if this x was 0, then the whole thing would be 0, but unfortunately we're going to have to work with what's inside, the parentheses in order to make this work. Now, here's the problem. This thing right here is such that it's secretly kind of like, well, it could be temporarily morphed into a quadratic expression. And then we could factor it and then kind of take it from there. Bottom line is, here's what I'm getting at. If this whole thing was 0, then it would be 0 times this x, and that would be 0. So let's force just this to be 0. All right, that's a good way of thinking about it. And in fact, you could sort of depart from the whole equation and just focus only here. Just be like, okay, I'm going to set this equal to 0, and I'm going to solve for x, because I know that will give me at least one of the answers, right? So we're going to do that. We have x to the 4th minus 5x squared plus 4 equals 0. Now, whenever I see this pattern of a leading exponent of 4 and then the middle exponent is like half that, what that means is that I should be, and they're both even, it should be such that, I can replace the middle variable with, I like to replace it with a z myself. So this is a decent strategy to use. Temporarily call it z. And what that results in is a situation where I can now call negative 5x squared negative 5z, right? And you might be asking, well, what about this? Well, that becomes z squared. It's always going to be that way, where whatever, if that's z, then this term becomes a z squared, right? Now if this was 10x to the 4th, well, this would be 10z squared, just to be clear, but it's the variable that I'm focusing on. We still have the plus 4, and nothing's changed about that. That's just a constant, right? Now, this is such that I should be able to factor this, so I could be like, all right, what factors of positive 4 are such that when I add them, I get negative 5? Well, that would be a 4 and a 1, and a minus and a minus. All right, now if you need more practice with factoring, you might want to look up like a Khan Academy video for factoring quadratic trinomials. Nonetheless, what we can see here is that z is clearly equal to 1 and z is clearly equal to 4. All right. Why do I know that? Because if z was 1, this would be 1 minus 1, which is 0. That would be 0 times whatever that is, and that would equal 0. If z was 4, that would be 4 minus 4, which is 0, and that would be 0 times whatever that is, and that equals 0. So if z equals 1 or 4, well, that means it's two situations. There's a situation where z equals 1. There's a situation where z equals 4. And according to our information, z equals x squared. Let's not forget that. So in other words, x squared equals 1. And we could also say that x squared equals 4. And of course, taking the square root of both sides here gives me x equals plus minus 1 and x equals plus minus 2. Because when you do the square roots of both sides, you have to do the plus minus thing right there. Square root of both sides, plus minus thing right there. All right, so hopefully that makes sense. So one possible solution is 1 or 2. Now let's really be clear. We're disregarding the negatives, right? So I'm actually going to blot those out with red because x has to be greater than 0, right? So it's either a positive 1 or a positive 2. The SAT would accept either of those, definitely. Moving on. All right, if 7x, blah, 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 what's the value of x? All right, well, these denominators are clearly annoying. There are multiple ways of getting rid of the denominators. I am seeing an opportunity right now to combine these. You might want to check that out. I mean, we have the same denominator here, so we could totally turn the left-hand side of the equal sign into 3/9 x equals 1/4 plus 5 over 12. 3/9, reduces into 1/3, so this is really 1/3 x equals 1/4 plus 5 over 12. Now, I have the option of just kind of adding these, right? I could be like 4 and 12 and multiply and find a common denominator and so on. But you know what? I just don't like denominators that are different. So I'm going to multiply everything by the LCM of 3, 4, and 12. So the denominators are 3, 4, and 12. I'm going to multiply everything by the LCM of 3, 4, and 12. And the LCM, the least common multiple of 3, 4, and 12 is 12. So I'm going to multiply everything, meaning both sides of the equation, by 12. Now, why would I do that? Well, this next step I'm going to draw out for my student at home so he knows exactly what I'm doing. I'm doing slow motion right now. Basically, that would result in a situation where you'd have 12 times 1/3 x, which we will get to soon. Obviously, 12 is going to distribute here and here. So on the right-hand side of the equal sign, it would be 12 times, 1/4 plus 12 times 5 over 12. And, at a certain level of skill, you're not going to have to write this line. You're just going to be able to see what's going on and make all these cancellations. But the cancellations we're looking for are the following. You're going to realize that could cancel with that. That turns into a 4. We're going to get to that later. Over here, we have the 12 turning into a 3. This turning into a 1. So you can see how we're knocking out the denominators. That's the purpose of multiplying the entire equation by the LCM. You end up knocking out all the denominators. And then, this 12 times that, 12 down there, well, that turns into a 1. That turns into a 1. We can analyze the fallout on the next line. So we have a 4, just a 4x, right? This is a 4x right there. It's 4 times x. And that equals, what is this? 3 is left over. And over here, we just have a 5 left over. If you look closely, this is a 5. So we therefore have 4x equals 8, and therefore x equals 2. We are done. That is the answer. X is 2. Moving. Okay, two isosceles triangles are shown above. If 180 minus equals 2y and y equals 75, what's the value of x? Okay, well, first of all, if you're being told that you're dealing with isosceles triangle, you might as well label those angles as being equal to each other and label these angles as being equal to each other, because these are the base angles of the isosceles triangles. Two isosceles triangles are shown above. 180 minus z is 2y, y is 75. All right, as soon as they say y is 75, I'm looking at that y, and I'm like, all right, cool. 180 minus z equals 2 times what? 75. And that is, of course, 150. So 180 minus z equals 150. What do you know? Z equals 30. That might come in handy, right? That might come in handy. So let's see if it does. So z is equal to 30. I'm going to write that right now. 30, yay. Okay, so so 30 right here plus this angle equals 180. I mean, these angles are the same. So I'm going to call this angle right here, I'm going to call that one. Let me just move things around a little bit. So I'm going to call, in green, this is A and this is A. And therefore we know for a fact that 30 plus A equals 180, no question about it. Therefore 30 plus 2A equals 180. 2A therefore equals 150. Dividing both sides by 2 gives me A equals 75. So it happens that this is 75 and that is 75. So we could do like the exterior angle theorem and so on. I have a feeling my student at home is not terribly familiar with that. So what I'm going to do is just understand that, this is 75. That is 75. And we'll just look at the fact that this 75 angle right here in x is a linear pair. So I know that 75 plus x equals 180 because, this angle plus this other larger angle form a straight line. They are therefore a linear pair. So therefore 75 plus x equals 180. And we could just solve for x from there, right? X is going to equal 180 minus 75, which is 105. That is the answer. Hopefully that makes sense. And, of course, you could always rewind it if need be. At a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does the hamburger have? So as soon as they say something like each hamburger has 50 more calories than each order of fries, so I'm going to say, H is like the amount of calories a hamburger has. And we are going to say that, fries. So F equals the amount of calories fries have, or an order of fries has. Now, according to the problem, once again, each hamburger has 50 more calories than each order of fries. So it's like one thing you could realize is that H totally equals F plus 50. And if 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does each hamburger have? Well, the other equation that we could totally set up based on this, next line, 2 hamburgers and 3 orders of fries have a total of 1,700 calories. Well, you could totally just be like, 2 times the amount of calories each hamburger has plus 3 times the amount of calories each order of fries has. That equals 1,700, right? And this is a system of equations where substitution is going to be fantastic. All right, now we already have H equals F plus 50, so I could plug in F plus 50 here and then kind of take it from there. But you know what? They want the amount of calories in a hamburger. Now, that means ultimately we want to solve for H. Now, when I want to solve for H, when it comes to this guy, I want to temporarily solve for F. All right, I know from experience that if I'm trying to solve for one variable, I first want to quote unquote solve for the other variable. and then do substitution. So this ends up becoming h minus 50 equals f. And then I could take h minus 50 and substitute it in for this f right here. Now you might be asking, how did I turn this into that? Well, I just solved for f. I subtracted this 50 from both sides, so f equals h minus 50. So anyway, I am now going to, these two are part of the same equation. This is the other equation. This is the equation. These are the two equations I am now going to be working with, however. So, when it comes to this one, let's go down here. We have 2h plus 3 times what? H minus 50 equals 1700. And, obviously we're going to distribute 3h minus 150 equals 1700. And therefore, combining, we have 5h equals 1850. And dividing both sides by 5 would give me pretty sure. Let me just double check. 1850 divided by 5, 315, 7, 35, 0, 0, 0, zeros all around. Yes, 370 is the answer. Hopefully that makes sense. We are done. In a triangle ABC, the measure of angle B is 90, BC is 16, AC is 20. All right, so as soon as they're getting into this gobbledygook, I don't care. I'm just going to draw it because otherwise it's too confusing. Now, it's worthy of note that angle B is 90, so let's try to draw it at least somewhat to scale. So ABC, the 90-degree angle is B. So it's going to be like, I'll just draw it like this. That's fine. 90 degrees right there. A, B, C. Okay, so BC is 16. I am definitely going to label that. I don't want that all in my head. I am going to draw it. AC is 20. And already I'm making a mental note. I do have enough information to figure out what AB is. I could always bust out the Pythagorean Theorem or special triangle. Triangle DEF is similar to ABC, where DEF correspond blah, blah, blah. And each side of the triangle is 1/3 the length of this. So DEF is a smaller triangle because apparently each side of DEF is 1/3 the length of this. So, DEF maybe looks something like this. I don't know, DEF. And that's the 90-degree thing right here. Now they want, what is sine F? Now sine F, that's the angle F clearly, right? We want sine of the angle F equals what, right? Well, sine, according to, our trusty, SOHCAHTOA thing, SOHCAHTOA is opposite over hypotenuse, right? That's sine. Sine is always opposite over hypotenuse. So sine of F is going to be the opposite over the hypotenuse. So in other words, the sine of F is going to be dE over dF, right? It's going to be, I'll use color coding. It's going to be dE over dF. It's going to be dE over dF, right? Because dE is the opposite, and the hypotenuse is the longer side that's across from the 90, so be careful with that. The hypotenuse is the longest side that's across from the 90-degree angle. That is dF. So we have dE over dF, right? Well, the problem is we don't have dE and we don't have dF. If this was a 5 and this was a 7, then it would be 5 over 7 and so on, right? But here's the good news. If this is similar to that, then the trigonometric functions and ratios are going to be the same because the side lengths are proportional, so they're going to reduce and all that. So that doesn't make sense. Just take my word for it. The trigonometric ratio of similar triangles will always be the same, and these are most definitely similar triangles, right? Similar triangles. So the trigonometric ratio of this triangle is going to be the same as the trigonometric ratio of the corresponding angles of this triangle. So what is the angle that corresponds with F? Well, clearly that is C. So really, we could just find, sine C. If we found sine C, that would actually be the answer, because sine C equals sine F, because this triangle is similar to that triangle. Okay, so let's find sine C, knowing full well that that is actually the answer to the problem. So how would you do that? Well, we need this opposite. What is this opposite? Well, I can tell that this is a 3, 4, 5 triangle where it's as follows. The 90 degree is here. I have a 4 times some number here. I have a 5 times the same number here, and this is going to be 3 times that number. Now, how did I know that? Well, I know that because this is clearly divisible by 4. This is divisible by 5. Then I asked myself, well, what times 4 gave me 16? 4. What times 5 gave me 20? 4, right? So the x in this case is 4, all right? So I'm going to write that. X in this case is 4. So in other words, 4 times 4 gives me 16. 5 times 4 gives me 20. And 3 times 4 will give me a 12 over here. So actually, this is 12 right there. All right, now if you don't like using the 3, 4, 5 triangle approach, because this is a special triangle, it's kind of like a famous triangle. If you don't like it, just know that you could use the Pythagorean Theorem, but just remember that the 20, this AC right here, that's the hypotenuse. The hypotenuse is the longest side that is across from the 90 degree angle. So you could call like this, 12, this could be like lowercase letter a, this could be lowercase letter b, and this could be lowercase letter c. And let's say, now of course we know that this is 12, but let's say we didn't know it was 12. You could have just said a squared plus 16 squared equals 20 squared, and you could have solved for a from there. Okay, I believe that's 256, that's 400. A squared would end up equaling 144, and then the square root of both would give you 12. All right. So the Pythagorean theorem would also work. Once you get the hang of this, though, it is faster. All right. Nonetheless, as I had mentioned before, really secretly, sine F is really equal to sine C. So we're like on this final mission to just simply find out what sine C is. And we're going to do that right now. So sine C, according to SOHCAHTOA, again, it's opposite over hypotenuse. So C is right here. The 12 is the opposite. So we're going to write 12 over the hypotenuse. And as I've mentioned, the hypotenuse is the longest side across from the 90 degree angle. Therefore, the hypotenuse is 20. So it is 12 over 20. That reduces, both are divisible by 4. 12 divided by 4 is 3. 20 divided by 4 is 5. So that reduces to 3/5 now. For the record, in the grid-in on the SAT, you can certainly write that as 3/5, or that would turn into a 0.6. You could put that in as well. All right. So that is the answer to this one. I hope all of this was helpful. If you have any questions or comments, please leave them in the comments below. And if you need tutoring, whether it's in person or over Skype, feel free to check out my website, sagemathtutoring.com. And good luck with everything. I'm going to do another video based on the kinds of problems that you could expect in the calculator section. So this, was an example of the kinds of problems that you could expect in the non-calculator section. And we're going to do the calculator section next, so stay tuned for that. All right, so talk to you soon. Bye.